Well, hi, hello, my dear students. Welcome to my video lecture class. Right up to now, I uploaded video lectures on the topic Newton's laws of motion. In this topic, I explained Newton's first law and its applications, Newton's second law and its applications, linear momentum and its applications, Newton's third law and its applications, and limitations of Newton's third law. I discussed it in previous lectures. Please go to that previous lecture for better understanding. So now, today I am going to discuss the most important topic for the NEET and JEE. So please observe carefully and watch the lecture till the end. Definitely you realize that you will realize that you got something new points from this lecture. So I'll start with fundamentals of this topic, and I explained applications based upon this. Please watch the lecture carefully, right? So the topic is, today's topic is law of conservation of momentum. 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 So first point. So already you know F bar net force is equal to dP bar by dt. dP bar by dt. Is it or not? So according to Newton's second law, F net is equal to dP bar by dt. So here momentum, for example, F external or net force, F net is equal to 0. If F net is equal to 0, then what will happen, ma'am? dP bar by here, if F net is equal to 0, then dP bar by dt is equal to 0. So then P bar is equal to constant or not? P bar is equal to constant. This is a total P bar. So P bar is equal to constant because d by dt of constant is equal to 0. If F net is equal to 0, then P will become constant. P will become constant. Easy. Is it or not? So whenever the net external force acts on any body is equal to 0, so then the vector sum of total momentum is equal to constant. So this is very important. So I'll write in words: if net external force acts on any body is equal to 0, then the total momentum vector sum is equal to is must constant. This is very important. Next, Newton's third law leads to law of conservation of momentum. Newton's third law leads to law of conservation of momentum. So Newton's third law leads to law of conservation of momentum. So next, applications of law of conservation of momentum are examples of law of conservation of momentum. Next, so the main examples, mainly problems are asked based upon this chapter. First one is explosion of bomb, or shell. Explosion of bomb or shell. Second one, disintegration of nuclei. Disintegration of nuclei. Disintegration of nuclei. So third one, recoil of gun. Fourth one, collision. So these are explained. So these are explained based upon law of conservation of linear momentum. So conservation topic. So these are explained based upon law of conservation of linear momentum topic. So this is very, very important. One is explosion of bomb, disintegration of nuclei, Next, recoil of gun, collisions. Problems also asked based upon these four topics only. Very, very, very important for the competitive exams. Please observe carefully. First, I'll start with a recoil of gun. Next, I'll discuss disintegration of nuclei, explosion of bomb, and collisions. These all concepts are explained, and problems are asked based upon these four concepts only. So these are solved mainly by using law of conservation of linear momentum topic. Right. So now, applications of law of conservation of linear momentum. Law of conservation of linear momentum. Applications of law of conservation of linear momentum. Alright, what is the major application? First, application number 1. Application number 1. Application number 1. Let us consider a gun of mass F of mass capital M. If bullet of mass small m, is fired from gun, moves with velocity small v, then gun gun moves backward with the same backward. Gun moves backward with some velocity, is called recoil of gun. Simple, don't panic here. For example, I consider gun. So bullet is fired from the gun. Bullet moves forward. For example, so let us consider gun. This is a gun. So bullets are moving from this gun like this. So this is a bullet. So bullets are moving forward direction. So gun will move backward direction. Because this is action and this is reaction. So from this gun, bullets are moves forward direction. The gun will move backward direction with the speed capital V. Here bullet is moves forward direction with the speed small v. Bullet of a mass small m. Gun of a mass capital M. According to law of conservation of momentum. Okay, so momentum of bullet mv is equal to momentum of, so here mass of the, here m means mass of bullet, v means velocity of bullet, capital M means mass of gun, capital V means velocity of gun or recoil velocity of gun. So this is according to law of conservation of momentum. So the momentum, so this is very important. Momentum of the bullet is equal to momentum of the gun, because this is explained based upon Newton's third law. So whatever the momentum of bullet, the same momentum will act on gun. So momentum of the bullet is equal to momentum of the gun. From this recoil velocity capital V is equal to small m into V by capital M. Okay, so this is recoil velocity. So recoil velocity m into small m into V by capital M. Momentum of the bullet is equal to momentum of the gun. So momentum of bullet is equal to momentum of bullet is equal to momentum of gun. Momentum of bullet is equal to momentum of gun. So this is very, very important. This is application number 1. So bullet is fired from the gun, then bullet moves forward with velocity small v and bullet of a mass small m. Then similarly gun moves backward, the gun of a mass capital M, and it is moves with the velocity capital V. Then momentum of the bullet is equal to momentum of the gun. Small m into V is equal to capital M into V. So this formula is very, very important. Okay, so this is application number 1. So this will be solved based upon Newton's third law. Okay, so next lecture we would like to discuss so application number 2 and 3. Okay, so I think you are all understood this lecture. So if you will get any doubt while watching lecture, please mention in comment box. So I hope you understood now. Again, I'll come back with new concepts and newer problems. Thank you for encouraging me. Thank you for supporting me. Thank you so much. Thank you.